Hello, everyone. Hi. We will get started in the next 5 minutes, give or take. Oops. There we go. We'll get started in the next 4 to 5 minutes. So yeah, go get a coffee, go to drink, use the restroom, get your homework out, and we will go over a few problems. All right, we have about 2 more minutes. We will start at 5:35. Let me just make a note. Okay. We'll give it 1 more minute. And then we'll go ahead and get started. Let's see, this is not, needs to be refreshed. All right. Cool. Let's just get started. So first of all, thank you so much for joining today. It's been a long week already, and we just started. It's only Monday. But that's all right. I am here today to help you out with geometry and or pre-cal. So if you have any questions, please, please, please do not hesitate. Do not feel shy. I can't see you. I don't know you. I just know you need help. So I can only know you need help if you tell me. So in the chat, you can tell me your question if possible. If you can't and you need to show me a picture or a screenshot, you can go ahead and email me here. Homework at systemtutoring.com. I just put it in all the chats. So just go ahead and shoot me an email of a picture of your problem or anything that you're struggling with, and I can definitely go over it during this session. So what happens is, if no one joins, I just go over some topics like pre-cal topics or geometry topics that I know students struggle with. I'm Pearl. I actually was a teacher for a few years. I taught algebra, geometry, pre-cal as well. I taught middle school math, and so math is one of my favorites. I really enjoy math personally. And so this is kind of my way of giving back to the community as much as possible, because I just love it. So yeah, we'll start with a little bit of geometry, and then we will go on to pre-cal. So for geometry for today, we went over last week volume and surface area of prisms and cylinders, but we never got a chance to hit pyramids and cones. So that's what we'll do today. All right, let me cross that out. Before I start, let me see, are there any questions? Nope. Any homework problems? I don't see any. So let's get started. Got my pen. Let's erase the sheet. And we're gonna start with the surface area of a cone. So, sorry, let me just make sure. Actually, let's do something a little bit, let's do a pyramid. Let's start with the pyramid. So I'm not the best at drawing images. I'm gonna do my best. Please don't laugh at me, but I'm just gonna do my best. So here I have a pyramid, and just like that, that. I think that's pretty good. That's pretty good. And I have my right triangle. Right triangles here. So the corners are right triangles, which should tell you immediately that's a square. But this is 4 inches wide, 4 inches long. And then I have a slant height of, so this height right here is 6.3 inches. And I'll just highlight it so we know that's 6.3. This is 4.4, and this is 4, and this is 4. Okay. So with that information, we can go ahead and find the surface area. So the surface area of a pyramid is kind of interesting. And all it is you take the, so surface area of a pyramid is just the area of the base, so big B, and you're going to add that to 1/2 the side of the base, or the side length, and then you're going to multiply that by the perimeter. Let me just make sure, and this S is the slant height, sorry. It's not the side. So the way we can do that is we can just point to everything. So this is the area of the base. That's a 1/2. This is slant height. And then this is the perimeter of the base. All right, pretty straightforward, right? So if this is our problem, then what we'll do is we will find the area of the base. So to do that, I'll start in the center here. So the surface area is going to be the area of the base, and the area of the base here is technically just length times width, right? Because the area of the base is a square, right? So square, that's going to be length times width. So when we do that, it should be just equal to 4 times 4 plus 1/2. Our slant height is 6.3. It's just the height of the slant of the pyramid. So 6.3. And then the perimeter of the base. We know the perimeter of the base is just you're adding up all the sides. So I just like to add them all up in here. 4 plus 4 plus 4. All right. So when we do that, we'll get 4 times 4, which is 16, plus 1/2 of 6.3. If you don't know that and you don't want to use your hand, you can always just use a calculator. This is the one that I use. It's a TI Inspire. I've had it for like probably almost 8 or 10 years, give or take. And it's even about to die. Oh no. But you can also use your phone if you would like, and just do 1/2 or 6.3 divided by 2. It's up to you how you want to do it. 6.3 divided by 2 or 6.3 times 0.5. When you do that, you should get 3.15. And then you have to multiply that by 4 plus 4 plus 4 plus 4, which we know is 16. Okay? So we do that math. 3.15 times 16 is equal to 50.4. So we get 16 plus 50.4. You add that all together, you should get 66.4. And what's very important here is when you are trying to write the answer to surface area of the surface area of the pyramid, you have to put the right metrics, right? So because this is inches, it'll be inches, but since it's area, don't forget it's inches squared. That's the surface area. Let's see, are there any questions? No questions. I don't see any. All right. So I guess we could move on. And we could do let's do maybe volume. Yeah, let's do a volume of a pyramid. But we need to know the height. And that might be a little bit much for this. So let's actually move on from that. All right, so we're gonna move on to another topic, and we're gonna talk about spheres. Oops. Okay, so when we talk about surface area of a sphere, this one is actually not too bad. So surface area of a sphere is equal to 4 times pi times r squared. So if I draw a sphere the best that I can, the way that I like to draw is like you draw a circle, but then you draw like a dashed oval inside. I don't know. That's the best I can do. And so if I tell you that from the center here, and I'll use a different color just so it's easier. If I tell you the center to here is, I don't know, let's say 3 feet, then you should be able to solve this, right? So all you would need then is you do 4 times pi and you just input your 3 feet, because that's your radius, squared. 3 squared is 9. 9 times 4 is 36. So your answer is 36 pi. If your teacher says, hey, I don't want you to put pi, I want you to put the full answer, then you could just say the final answer is 113.1. Don't forget, when you're dealing with surface area, you need to have your metrics. So your metrics here were feet, so it's feet, and when you're dealing with area, it's squared. All right. We can try another example. And so in this example, I'll draw my sphere again. So it's a circle, and then we have like a dash, semicircle of some sort, or oval. And then instead, across the entire diameter, that is going to be 12 centimeters. So when we're solving for our of a sphere, I was going to say solutions architect, but the surface area of a sphere, you'll just do 4 pi r squared as usual. And then here, they've given us a diameter. So if they've given us a diameter, we should know that if d equals 12, right, then r is equal to d divided by 2. So that means 12 divided by 2, r is equal to 6. So I can fill this in with 6, and that's squared. And then we go back to solving. 6 times 6 times 6 is 36. We should know that. And then 36 times 4, that is 134. Let's see. Oh no, my calculator died. Let's use this. Okay, so 36 times 4, 144. 144 pi. Again, if your teacher says, I don't want you to use pi, I want you to give me the exact answer. 144 pi, 144 times pi, or 3.14, should give you 452.4. Don't forget your metrics, which is centimeters, and because you did surface area, it is squared. Okay, we have about 3 more minutes here, so we'll do one example, because I don't think we did that last time. We did surface area and we did volume of prisms and cylinders and pyramids and cones, but we didn't get a chance to do volumes of spheres, so let's just do that. So the volume of a sphere, let me just make sure there are no questions. I think we're okay. And if you're just joining in, we are going over some geometry and pre-cal. If you have any questions about what we are learning or you need any guidance or support, you can ask a question in the chat, or you can go ahead and shoot me an email here. There. Send a picture of your homework and I'd love to help you. All right, so now we're going to deal with the volume of a sphere. So the formula for a volume of a sphere, also pretty straightforward, and that's just equals, volume equals 4/3 pi r cubed, which makes sense. So you're basically taking the area of a circle, right, which is pi r squared normally. You're going to multiply that by another radius, another r, and then you're going to multiply that by 4/3. So in our question then, if I draw a shape, I can draw a circle again. Make that better. Not very good. Fine, whatever. And then we draw our little hollow thing. We can say now that this entire diameter is 16 inches. And so if we want to find the volume, we need to go ahead and say, we know we're going to need to find r, and r is equal to d divided by 2. So 16 divided by 2, r is equal to 8. All right, so let's go ahead and solve. So the volume of a sphere for this sphere is 4/3. We're going to multiply by pi, and then we're going to replace r with 8. Okay? And we're going to cube that. So I don't have my calculator anymore. I just have my phone, which is fine. And we'll just do 8 times 8 times 8, which I believe is 120, or it's 512, sorry. 512. So we'll get 4/3 times pi times 512. And so if we put that in the calculator, we do that math, you'll get I'm multiplying everything through because I got a decimal. You should get 2143.57. And don't forget, similar to all the other metrics, all the other examples, sorry, we need metrics, and then this one is inches, and because it's volume, it's going to be cubed. So this is our final answer. Actually, this is clean, so you can see that it's a 3. All right, that's how you find volume of a sphere and surface area of a sphere. So yeah, any questions? No questions yet, and no email. That's fine. Let's move on to some pre-cal. Looks like I might need my calculator for some of these. I want to find something where I wouldn't need a calculator. Okay, let's see. All right, I guess we could do this. We won't need a calculator for this. So in this particular lesson for pre-cal, we'll talk about parabolas. And all you need to know about parabolas is that they're that U-shaped. So whenever you see a U-shaped graph like so, that's a parabola. Whether it's up and down, it can also look like this. Don't be afraid, it's the same thing or same kind of thing, just right and left. And I'll show you 2 examples of that. So when we see something like this, when we see the up and down one, the reason why we know that it's up and down really is because it's really because of the equation. So the equations matter here. So the question I have, or the formula that you'll need, is the vertex form. So vertex form of a parabola, there's many different forms, but this is vertex form. It's something like this. So it's y equals, I'll put a in the front, and then it's x minus h squared, don't forget your squared, plus k. Okay. And so your A tells you how stretched your graph is. Is it really, really narrow? Is it really, really wide? How big, how stretched is it? So when I think of A, if A is greater than 1, then the graph tends to be pretty narrow. Okay. And then if A is less than 1, but greater than 0 or a fraction, then this is normally like a wider graph. And then if A is less than 0, then this will be a flipped over. So the graph, instead of being up, will be turned like this. Okay. Let's see. And then I'll do this one just in case. If A opens, if it's greater than 0, so it's flipped up. So it looks like this. So if it's A is greater than 1, like I said, whether it's flipped up or down, it doesn't matter. So if A is 2, 3, 4, that means the graph is going to be very just like super narrow, depending on the number. And then if the number is between 0 and 1, so like a fraction, I always think like 1/4, 1/3, 2/5, whatever that it might be, the graph is more like flat. It'll be more like this. Or it could be like this. It doesn't really matter. And then this flipped over means negative. So A is negative. You don't get confused. And here A is positive. So you could have A being a negative, but then a fraction. That means that you know that the graph is flipped upside down and it's wider. Okay. I'll move on to the next page and I'll carry this over. So y equals A x minus h squared plus k. So we did A. Now we're going to talk about h. Okay. So h is important because it tells us about our graph and moving left and right. How much over is our graph moving from the vertex form? Is it moving left some, right some? How do we know? So it's called a horizontal shift. Horizontal or left, right movement. Okay? It moves opposite of the sign you see. So if you see like something like this, x minus h, you in your mind would think, oh, it's a minus sign, so I should move left. No. So be careful. Move, if you see minus something, move right h. If you see x plus h, you move left, whatever the h is. Okay? What else is very important is if somebody asks you what the axis of symmetry is, you should immediately know it is h, whatever the h value is. And then one more thing about h. H is the x coordinate of the vertex. Okay. Any questions? Let's see. All right, no questions. So now we're going to talk about k. A x minus h squared plus k. So k is vertical shift. Okay? Up, down movement. So if you see plus k, that means the graph moves up. Whatever that amount is, up k. If it's 3, up 3. If it's 5, up 5. We see minus k, down whatever the value of k is. Down 5, down 4, whatever that it might be. What's important here is that k is the y value of the vertex. What else is also important is that if if a is greater than 0 or opens upwards, or let me say the words we use, or is flipped up, then your k is the minimum value. If a is less than 0 or is flipped down, then k is the max value. And we'll talk more about what that means in a little bit. So we have all the differences between a, h, and k. And I want you to know something here before we continue, that vertex has this look. So whatever your h is, comma, whatever your k is. This is super important. All right, so quick recap. We did vertex form. It has this particular setup right here. And then A is based on the stretch or the shrink of the graph, meaning how narrow is it? How wide is it? Is it upwards? Is it flipped downwards? How do we know? And these are the ways we know. So if A is greater than 1, so 2, 3, 4, 5, 6, it looks like it's going to be a more narrow graph. If you have A is a fraction, 1/4, 1/3, 2/5, 2/3, whatever, you're going to have a more wider, flatter graph. If A is negative, if you have a negative sign in front, automatically the graph is upside down, it's flipped upside down. And then if A is positive, you know your graph is flipped over, flipped up, right side up. And I'll change this to flip down. When we talk about H is about horizontal movement of your graph, moving left and right. So if your graph has a negative H, you're actually moving right that amount. If you have a positive H, you're actually moving left that amount. It's just the opposite sign, opposite movement. When they ask you what the axis of symmetry is, it's going to be your H value, whatever that number is. Your H is normally an X value, by the way. And because of that, H is the X coordinate of your vertex. This will make sense shortly, don't worry. And then we have vertical shift, which is your K. That is your up and down movement. Does your graph move up or down? So if it's a positive K, your graph has moved up. If it's a negative K, your graph has moved down. And K is the Y value of the vertex. Key thing here, if your graph is flipped up, meaning it's upright, then your K value is at the very bottom. That's the most minimum value that your graph can go. And then if A is negative or flipped down, that's the maximum. The Y value there in the center is the maximum the graph can go. So that will make sense in a moment. When we talk about when we talk about graphing these things, what we're saying is we have a general y equals x squared is your general quadratic, right? And I'll actually move that so we can see it better. So y equals x squared, that's your general parabola. There's no movement. It starts at 0. There's a 1, 1 coordinate here. There's a 1, 2, 1, 2, 3, 4. There's a 2, 4 coordinate here. There's a 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And there's a 9 here, 9 here. So this is how your general quadratic looks like if I was to draw one, right? And I'll just draw it dashed. But what your vertex form is telling you is that this graph can be moved left and right. It can move this way. Well, let me use the right colors. It can be moved right. It can be moved left. So this is positive H. This is negative H. Like that. It can be moved up. That's plus K. It can move down. It's minus K. It can be more narrow. So we can make it more like here, here, or it could be more wide. We can have it like here or here, depending on how your graph is graphed. So that's what we're trying to show you here with vertex form. So when we want to graph vertex form, we want to know what change is happening to this blue or this regular, your family quadratic parabola. So if I have a problem here, let me pull one up. Sorry, I had one ready. Okay, cool. So I have a problem here, and I'll go to this page so we can have it, and I'll just keep this as a white paper. So the problem we have is y equals negative x plus 3 squared minus 1. So this question is asking us to find the vertex. Oops. It's telling us to find the axis of symmetry. And they want us to graph it. Okay, it's not too bad. We're just gonna figure out what's going on. The first thing is we're gonna figure out what our A is. A is negative. So graph is flipped down. We know that when there's no number beside here, it's just a 1, right? We don't have to write that in. We know it's a 1. Because it's 1, nothing is happening. The graph is not being flattened, it's not being widened, it's just flipped over because it's negative, right? When we talk about H is positive. So graph is moving left 3. And then K is negative. So graph is moving down 3. I keep saying 3. 1. So based on what we know that our H and K is based on, our vertex, is based on H and K, like so. So we can say that our vertex is not actually positive 3, it's going to be negative 3. The reason for that is because we are moving left 3. So it's going to be negative 3, comma, negative 1. That's our vertex. Left 3, down 1, and we can do that on our graph here. So if we go here, this isn't our regular graph, and again, we're moving left 3, so 1, 2, 3, and we're moving down 1. So it looks like our new graph, which I was in a different color, let me use orange or purple maybe. So this is our new vertex, negative 3, 1. All right, so now that we know that, we just need to do that with all of our pieces or all of our points. So we're gonna move all of our points over 3, down 1. So we'll start here with this one. 1, 2, 3, down 1. So right here, this one as well. 1, 2, 3, down 1, right here. Same thing here. 1, 2, 3, down 1. I use green so he knows down that way. Same thing here. 1, 2, 3, down 1. We're right here. But there's something key here that we're actually missing, and we'll see in a moment. I'll finish it off and I'll show you the problem. So 1, 2, 3, down 1. Same thing here. 1, 2, 3, down 1. So this technically would have been our new parabola, right? But the issue is we're forgetting about our A. We're only been dealing with yellow and green. You have to be able to flip your points because it's a negative A. Don't forget, A is negative, so it needs to be flipped down. So this is actually all incorrect. All incorrect. You can't just move your graph left and right if A has a value. Our vertex is right, we can keep that, but we have to flip over our points. So to do that, all you're gonna do is move the same amount. So we'll do 1, 2, 3, and then we move down 1, but instead of it being here, you flip it here. So normally it'd be right here, right? So put it right here. Then flip it. Same thing here. If you don't want to do all that counting because it's getting all in the way, I would just mirror it. I would just count over and mirror it. So from here, I'll use it again. From this point, 1, 2, 3, across, down, mirror. All right. Let's do the same thing with these points. 1, 2, 3, down 1, right here. Mirror it. Here, 1, 2, 3, down 1, right here. And what I'm doing, so if you don't really see what I'm doing, I'm going like this. So I'm going 1, 2, 3, down 1. This is where it normally would be, right? We have to flip it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 to the vertex, 9 spaces to the vertex. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9 from the vertex down. So this is actually where it should be. Same thing here. I'm going to go left 3, 1, 2, 3, and then down. This is normally where it'd be, but since our A is flipped, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 again to here against the vertex, and then 9 again down from the vertex. So this is where your graph is. All right. So this is y equals negative x plus 3 squared minus 1. Cool. I spent a lot of time with my head down, so I didn't see if there were any questions. But we are at time, we're even past time. So I'm going to let you all go. And if you have any questions for me, please go ahead and email me, homework@systemtutoring.com. If this was super helpful, let me know. If it wasn't and you're just in ways to improve, also let me know. I don't mind. Follow me on Instagram, LinkedIn, the whole nine. I'm all over. So I'll send you my, let me quickly post my, I'll post my social media so you can follow me there. I go live every Monday and Wednesday. On Mondays, I do algebra at 4:30, and on Mondays at 5:30, I do pre-cal and geometry. And then on Wednesdays, I do chemistry at 4:30 and physics at 5:30. So again, if you have any questions or you want to follow us or see what we're up to, please do not hesitate to follow me on all the social medias here. I'll post them in the chat. And yeah, thank you so much for joining. Have a great rest of your week. And if you need help with physics and chemistry,